In this section, we're going to do some more work on graphing of lines. We're going to talk about how to find the intercepts of a line and use them to graph the lines. And then we're also going to look at these two special lines, horizontal lines and vertical lines. Okay, here's some good things for your notes. The x-coordinate of a point where a graph intersects the x-axis is called an x-intercept. To find the x-intercept, you're going to let y equal to 0, and then you're going to solve for x. So you're going to use the equation of your line, set y to 0, and solve for x to find the x-intercept of the line. Similarly, the y-coordinate of a point where a graph intersects the y-axis is called a y-intercept. And to find the y-intercept of a line, we're going to let x equal to 0, and then we'll solve for y. And we're going to do some examples below. So as we go on, you're going to see some examples of how to find intercepts and use them to graph lines. We're also going to talk about these two special lines. So here, the equation of a horizontal line that has y-intercept b, so some number b, could be 2, 3, negative. The equation of that line is y equals the y-intercept b, so y equals b. And the equation of a vertical line with x-intercept k, and that again, k is some number, that equation is x equals k. X equals a number. You'll see those below as well. Alright, so let's look at the first example, finding intercepts. And we're going to use the intercepts to graph each of these two lines. So the first line, 2x plus 3y equals negative 6. And I think we should find the y-intercept first, although that's just a matter of personal choice. So as you know from your notes, to find the y-intercept, we're going to set x equal to 0 in our equation, and we're going to solve for y. So I'm going to substitute 0 where x is, so 2 times 0 plus 3y equals negative 6. Of course, 2 times 0 is 0, so we get 3y equals negative 6, and dividing by 3, we get that y equals negative 2. So the coordinates of the y-intercept are 0, negative 2. And let's go ahead and graph that. And again, makes sense that it would lie on the y-axis because that's why it's called the y-intercept. It's going to lie on the y-axis. Okay, now we'll find the x-intercept. This time we're going to set y equal to 0, and we'll solve for x. So go up to your equation, and again, substitute 0 where y is. So we get 2x plus 3 times 0 equals negative 6. And of course, 3 times 0 is 0, so we just get 2x equals negative 6. And when we divide both sides by 2, we get that x is negative 3. So the coordinates, or the order pair, is negative 3, 0. That's the order pair that goes with our x-intercept. This is where the line is going to cross the x-axis. And so we're going to use those 2 points that we just found and graphed on the number line, on the plane. We're going to use that, connect those 2 dots, and that gives us the line 2x plus 3y equals negative 6. Okay, here's another example. Negative 5x plus 2y equals 10. We're going to find the y-intercept. Again, you set x equal to 0. So we're going to substitute in 0 where the x is. Negative 5 times 0 is 0, so we get 2y equals 10. Dividing both sides by 2, we get y equals 5. So 0, 5 is our y-intercept. That's our coordinates. So we're going to graph that. And now let's go to x-intercept. Here we set y equal to 0 and solve for x. And so we're going to substitute in 0. And we know 2 times 0 is 0, so we get negative 5x equals 10. Dividing both sides by negative 5, you get x equals negative 2. So negative 2, 0 is the order pair that goes with our x-intercept. and join those two, and that gives us the graph of the line. Now let's look at horizontal lines. It says graph the equation and identify its y-intercept. So the y-intercept is 0, 1 from our notes above, remember? And so we graph y equals 0, 1, and then just draw a horizontal line, and that's your graph of y equals 1. Okay, x equals -2 is a vertical line. Its x-intercept is -2, 0. Put that dot there on that, put that point on the x-axis, and then draw a vertical line through that point, and that's going to give us the graph of x equals -2. In the next exercises, we're going to write an equation for the line satisfying the given conditions. So we want a vertical line that passes through the point -4, 4. Well, you know that a vertical line has equation of the form x equals some number. And all of the x coordinates of the points on this vertical line are going to be the same, and they're going to be that number. And for us, that's -4. So the equation of the vertical line that goes through -4, 4 is x equals -4. That's the equation of that line. Okay, now we want a horizontal line passing through the point 5, 1. I'm going to graph this so you can see it. So here's the point 5, 1. Go ahead and graph the horizontal line. Well, this looks familiar because we had it above. All of these points have y-coordinate equal to 1. And notice also our point has y-coordinate equal to 1. So the equation of a horizontal line that passes through 5, 1 is y equals 1. Now we're going to look for a perpendicular line, a line perpendicular to y equals -2 and passing through 0, -6. So we're going to graph the point 0, -6 so that you can kind of visualize where that is. And then we're going to graph the line y equals -2, which we know is horizontal. And so we find 0, -2 as the y-intercept, graph the line, and a perpendicular line would be a vertical line. Remember, perpendicular lines make right angles. So perpendicular line would be vertical line, and if it has to go through 0, -6, well, it's got to be the y-axis actually. And the equation for that y-axis is y equals 0. Excuse me, x equals 0. And again, that's our x-coordinate of our point. So x equals 0 is perpendicular to y equals -2 and passes through 0, -6.